Hello and welcome everyone to our final nature adventure of the semester. It takes a few minutes for all our attendees to get into the webinar room. So as you're coming in, go to the chat window and tell us where you're joining from, your city and state, and if you're an at-home learner or if you're joining us from a classroom. Also, let us know if this is your first nature adventure or if you've been coming back, returning for more all semester. Today, we have a really great program for you. We're going to learn about sharks and fossils. How cool is that? You'll even learn where and how to look for and find your own fossils. And then we just found this really new cool tool that we're going to use at the end. Hopefully, if you have fossils at home that you can share and tell back with us about what you have found already. So before we get started, we'd like to review a few rules related to the virtual environment. We are using a Zoom webinar room today. In the webinar room, you do not have the option to turn your video camera on. So you should only be seeing the presenting host and panelists for today's program. For today, that's me. I'm your host, Angela Brisson, and then we'll be joined by Jonathan J.P. Peoples, who will be our main presenter. The chat function has been set to panelists only, meaning you can communicate with us through the chat window with the presenters and host. This is all for the safety and protection for all of us in the virtual learning environment to prevent things like Zoom bombing and keep you guys safe out there. At certain points during the virtual learning session today, our presenter may ask you to type in the chat to answer questions or provide feedback. We'll let you know when those designated times are. But if you have questions, you're welcome to enter them in the chat window at any time. We're going to do our best to stop for questions a few times, but we may not be able to answer all of them. Please note that today's session is being recorded, and please be respectful of each other, our presenters and hosts in the virtual environment. Inappropriate language, bullying, or other types of negative behavior are all grounds for dismissal from the program. This program is provided by the North Carolina 4-H Camping Program as part of NC State University and North Carolina Cooperative Extension. Our 4-H Camping Program includes 3 centers all across the state. We run fall and spring school field trips at these centers, as well as operate traditional summer camping programs from June through August. And that includes things like swimming and hiking and horseback riding, arts and crafts, and lots more. You can check us out at nc4hcamps.org to learn more. We do have a learning and discussion guide for today's program, which is a worksheet that you can use to follow along and track your learning. I just put the download link for that in the chat window. And now I'd like to introduce JP, our program director from the Eastern 4-H Center. You may remember JP from our very first adventure this semester on coastal ecology, and he's come back to send us out with a bang here in December. He's been searching and finding fossils in North Carolina for well over 10 years, and he's going to share his personal fossil collection with you today. It's really cool. This is one of my favorite nature adventures. So with that, I'm going to pass it over to JP.
All righty, thanks guys, and good to see you again if you are a returner, or good to meet you if this is your first session. As Angela told you, I've been collecting, I think, close to 15 years, all through college when I was in Greenville, which is a place where you can find them commonly, and we'll go through that. But for quite some time, I've been doing trips and going places and trying to find new areas, and we'll get into some of it. So for starters, she was saying you can use a chat here. You see the first one, we'll kind of go through this kind of squiggle of lines here and go through our Prezi. But for the first one, what are fossils? You may have seen one, you may have found one, you may have some that someone gave to you, or you may have gone through a lesson like this before and got one at the end of it. So in your definition, what is a fossil? And you can just drop that down into the chat down there, and now we'll look and see what people say. We'll kind of go through a formal definition here in a minute, because it's not just like a shark's tooth. It's a broad spectrum of what fossils are and those sorts of things. So we'll go ahead and get on into it. They are the or as a mold or a cast in rock. So that's a really long definition, right? Essentially, it's the remains of something that is used to be living and now it's preserved in some manner. And so we'll get into some of the forms in which it can be preserved. Um, a very kind of common one you can see in a lot is kind of mold form. And this is essentially where you see right here the shell. It's like an impression. It's not even the actual object. It's the impression of where this object laid down in the sediment, and then all this fossilized material sat there, was covered up by ocean waves or what have you, and then this remained in some sort of rock or sandstone after that. The next one is a cast fossil. So this is more of a 3D object. I can actually show you this one right here, and we'll show you some of these closer up at the end. This is a piece of coral, super light. It's like you're not even holding anything, but it's still a 3D object, and it fully represents what you had, what this object looked like when it was prior to fossilization. You get lots of little small details and those sorts of things with this type of with you, right? So, the reason these are known as the true form fossil is that they are exactly how they were when they were living organisms, or if they were plants or stuff like that. So, the two main examples are like if they get buried in ice, aka the woolly mammoth, like that, or if you've seen the first Jurassic Park, I think it's in the second and third one as well, where the scientist, the lead scientist, the tour guide, as it were, his find mosquito from Martin, the whole story. That's a really really prime example of a preserved remains, and it is exactly how cool. A really rare one, but a really fun one to find is a trace fossil because you get to see and study activity and behavior of is different in the fact that you're seeing a footprint or you're seeing like sometimes you'll see a trail of some worms in a rock and stuff like that, trilobites and those sorts of things come to mind. So really hard to find though, and finding those on the East Coast is almost impossible. They're more like in hardened rock that's been uplifted and things like that. And then the one that is very common is a petrified fossil. So you have petrified wood. You find those out there in the Rocky Mountains in those areas. Not so much on the East Coast again. But then you have shark's teeth, and that's what we're going to talk about pretty much today. And they go through a process called permanentization. So if you have a shark's tooth that just falls on the ocean floor, it's white as it comes out of the shark's mouth, right? And so after it settles and settles and gets covered up and packed in, and pressure happens, in about 10,000 years, a process happens where the tooth, the elements of the tooth are replaced with the minerals and things that surround the tooth. And that's also why you get different colors of fossilized shark's teeth. If it's petrified with copper, you get sort of a red color. Petrified with sandstones for sort of a white color. And there's also lightning shark's teeth. You can look those up, and those have little streaks that'll run right down the thing, and that'll be where a root kind of came across the blade of the tooth. Really cool stuff. Again, with all these topics, I'm scraping the surface. You can go and dig into this, and the possibilities are limitless. People do PhDs on shark's teeth, get doctorate degrees and stuff. Next up, we're going to talk about kind of where they are. I mean, there are many locations you can find them. And if you just go out to the street and ask someone, they're not going to tell you their favorite spot. It's like someone telling you their favorite fishing hole. They might get you close, they might tell you how, but there are a few places that are so widely known that we can't talk about them. And a lot of them are in creeks. Freshwater creeks used to essentially be where the ocean was, millions of years ago. Then with continental shift and things like that, you're exposing a layer of fossils in this area. So this is a typical setup. You have this big shelf over here, all these bigger rocks. You have a screen, and we'll show you some of that. One really important thing of this is if you go out, make sure you have permission to go to this location. If it's on private property, you have to have permission. If it's in a public park, not so much. But even some public parks have stipulations on what kind of tools you can use or how much you can pull out and those sorts of things. So just really be aware if you're going somewhere other than places that I mentioned today, that you have to kind of look it up. And of course, let someone know that you're out there, or take a buddy if you're going to go on a little trip. Next up, I'll show you what I use to collect. This is by no means what everyone uses, but it's just what I use. Waders are important to keep the water that's usually kind of cold off of you. I use a 1/2 inch screen. These are like for boating sort of situations. It has a little carabiner on it. You'll see this in a video here momentarily. A shovel, I like a short shovel. Some people use a long blade. It's up to your preference. And then I use this little fishing vest in case you find anything cool, want to keep water with you, or bug spray or sunscreen. And these are some of the things that you need. But on top of all of it, you need patience. Once you go out to an area that let's say it's fossil rich, it's not the most natural thing to look for shark's teeth. But as you start finding them, be like, oh, I see a little piece of one over there. I see a whole thing over there. Is that a piece of a root? You can really get an eye for what's going on in the background. I see the chat lighting up down there. Make sure if you guys are putting stuff down there, questions, we will talk about those in the end here in a little bit. We'll wrap it up. So how old are they? How old are the shark's teeth from the ones that we find, and how long does it take? Essentially, shark's teeth, or generally, shark's teeth to 140 million years ago old. A lot of these are extinct species that you're finding now. A lot of it depends upon which era of the formation that you're finding it. So you may hear me later talk about the Pungo Formation or the Yorktown Formation, and these are different eras of time where fossilized material are coming from, and that really depends upon and helps you identify things as well. As a general rule, it takes at least 10,000 years to fossilize into the petriform forms that we can find today. So if you are out there and you see a fossilized tooth, it's at least 10,000 years old, but it could be upwards of 100 million years old or older. All right, why so many? And I will show you an actual unfossilized shark jaw here in a minute, but you can see the layers on this one just a little bit, and that's why. They don't depend like us on baby teeth and adult teeth. They have rows and rows and rows of teeth that just roll out. And at any given time, most sharks have at least 5 rows of teeth, and their rows contain a whole lot more teeth than we do. So if a shark, say, lives to be 50 years old, and he's losing a row of his teeth every year or two, that's a lot of teeth that just land out on the ocean floor. And to fossilize. Not all sharks teeth fossilize though. A lot of them are broken up, a lot of them degrade, a lot of them get turned into sand, just like shells and things like that, they return back to the ocean in the form of sand. So it takes a particular environment for them to fossilize. All righty, moving along. So I'll show you kind of the areas that we go to. I went to school at ECU, East Carolina University, which is in Greenville, North Carolina. And there's a little place called GMR, or Green Mills Run, that is very, very popular, very kid friendly. And a place that from down from the road from there is the town of Aurora, North Carolina. I think they have one stop sign, but they have an awesome museum down there. They have a phosphate mine that they've been digging material out of for about 20, 30 years now. And in that material is the most fossil rich environment that's known in the United States, at least. You can find them also on the beaches, but it has to be the right beach. You can't go to the Outer Banks, where I'm near to out here, and find them, but like North Myrtle Beach or Onslow Beach, places like that, you can find them. And it all depends upon where those sediment layers are in correlation to the beach. So what we'll also get into is how things change in weather. That was another safety tip. So this creek right here is the same creek you saw earlier, except this was after a tropical event. And this in the town of Greenville is like 12 foot above sea level. So this could happen almost any time like this. And you'll have ages in different parts of the creek. So this is a little bit difficult to explain, but I'll try my best. Let's act like my arm is the creek over the course of about 2 miles, right? So the water flows downhill, it's gravity fed. It's not very rapid, but over time, you'll have these different layers of sediment that it exposes. So that's my best way of explaining it. If you're upstream, you're finding more recent material. You're going to find more shells. You're going to find more things of that nature. If you're find a lot more, in the certain areas, you're going to find older material because it's packed in lower. the creek is exposing or has already exposed the newer material and washed it away, and now it's exposing the older material. But I can address it again if we have questions about it. It is a little bit confusing, but it's something if you were to get into this and get your equipment and start going, you will realize where the line kind of changes on those sorts of things. And next up, we have a video that goes into sifting techniques. I believe Angela is going to show that on her side because we were having issues with it earlier.
Yep, so give me just a minute. And so this is a video of JP actually out in a creek looking for fossils. So I'm going to share it. And there's no sound, so he's going to tell us what he's doing as we're watching the video.
So basically, you see the creek here. You see my shovel, my setup, my waders, all the equipment I showed you before. And something I point out here in a minute is there's lots of trash around. You know, we as humans are unfortunately litterers by accident or by, you see the can there. I tried to put it to the side, A, for safety so I don't cut myself, but B, just if I have a bag or something, I'm going to take it out. But other than that, you see the sifting technique, pull it out of the water, shake it around, look at it over first, and then there you go. There's a shark's tooth. You know, you're not going to find one in every screen. You're also not going to, you know, be able to, you know, find multiples in the screen very often. So patience is a virtue. Um, and this is in Greenville. This is in the Green Mills Run. It's in Green Springs Park in Greenville, North Carolina. A very common place. If you type in GMR Greenville fossils, tons of information on the Google machine there. And then you just keep back and you go back to it. So it's something that you can easily get into, and it was something that it you know it takes time. It really does. You kind of saw my technique there, and you're kind of shaking around. I didn't put that much material on there so that I could show you an example. Sometimes I will overstuff it and move it around and take out the big chunks and really be able to see all the material. And it depends upon what you're after, what kind of sifting you do. Some people have the little micro screens, like the little that are like a quarter or maybe an eighth of an inch in size. I like to use half inch because you find bigger teeth, and a lot of the things that are in the creek go straight through, and you don't have to worry about sifting them out or picking them out.
Hey, JP, before we move on, there have been a lot of great questions, and I want to keep up with the questions in the chat. So if you don't mind, let's pause for just a few questions before we move on.
Sure.
So the first one is from Kim, and she asked, what type of fossils are shark teeth?
So fossils are the petrified remains. Those are the ones that are just completely replaced. So if you have a shark's tooth here, right, and we're gonna do some show and tell. But this shark's tooth used to be, this object used to be in a shark's mouth. This is a mako tooth. Then it fell out of the shark's tooth, and all the minerals that were in this original tooth are completely replaced. So this is now basically a piece of sandstone in the same form and shape and sharpness as its original form. So it's a permanentized, fossilized item.
Great question.
Yeah.
And then this is a fun question. Evermay asks, can clothes become fossilized?
Can clothes become fossilized? Unfortunately not. Things like shark's teeth are made of harder, more durable materials than clothing. Maybe some things like leather potentially, but I don't even think like that would stick around long enough. It would just completely biodegrade in almost any environment we have. You know, with the fossilization process taking 10,000 years, most things that we would wear are going to fall to the wayside in that amount of time.
Awesome.
Good question. Then.
Yeah, great question. And then this is a good segue follow-up question to that as well. Candace asked, why does it take so long for it to become a fossil?
It takes so long because if you have a tooth that falls out and it has to really break down and it breaks down the surface of the tooth, and this is getting to a whole nother topic, but it breaks down the surface of the tooth and it has to find I'll try to find a good example of it. There's always a little hole that of the tooth. I don't know if you can see that. And that's called the nutrient hole. And so when you get to that point in the process where, hey, the outside environment is right, it has the right amount of pressure, and it's been there for long enough that it will break down the barrier of this tooth, and it will start slowly replacing the initially. almost all teeth and all fossilized materials that are permanentized have this nutrient hole. Great question though.
Great question. And let's see. One last question. I just had it. Where did it go? Can you tell how old a shark is by their teeth?
It's really, really difficult to do that because they replace them so often. They don't have time to make growth rings. So a lot of teeth and things you can tell by growth rings and other, especially aquatic mammals. You can find those things, but since they lose their teeth like yearly or daily, sometimes with certain species of sharks, they don't have time to tell. You somewhat can tell with the size of them by some species. So, like if you have a megalodon tooth that's this big, and it looks like it's in the center of the jaw, not laterally or posteriorly, then you can tell that it was some degree of age. We don't actually, as a society, know how old megalodon sharks could live. So it's a difficult question. It really is. But generally speaking, if you have a tiger shark today and a tooth falls out and you look at it, you can say, well, it's an adult. That's about as far as you can get with the teeth.
Awesome. Thanks, JP. And we have more
Yeah.
questions, but we'll keep those for the next time. Keep the questions coming, and we'll get to them a little bit later and let JP continue on with the program.
Very cool. Thanks, Angela. So
Mhm.
next up, we have the anatomy of a tooth, which is basically the you know the, the kind of the items on a tooth that we label and we talk about. So if you find it in the creek, you're like, oh man, the root's gone. You're talking about the top part here, and this would be the part in our teeth that's in the gum. So this part down here, the root would be kind of hidden even in a shark's mouth. The enamel, or also sometimes called the blade, I think you've heard me already refer to it as that. We have enamel, and we don't. It's a little bit different. We also don't have serrations. That would be kind of scary, right? So the serrations are razor sharp, and even in a fossilized shark's tooth, they can still cut you. They can still be very, very sharp. And then you have the tip. Lots of times you'll pull a tooth out. I mean, oh man, don't be complete, be complete, and then the tip's gone, or this root lobe. Sometimes you call this the root lobe will be chopped off, because what you have to remember is it was in the ocean, it got permanentized, it got fossilized, and it sat there, and then this millions of years happened, and then this creek's coming through all of a sudden, and it's running around, and some of the teeth I have might have been tumbling around in a creek for thousands of years, and they hit something just right and break off a tip or a lobe. It's unfortunate, but it happens. Still cool to find those things though. And so now we're going to do a little semi-trivia educational event. So these are some of the more common species, at least these four are. And we have the rare species over here we'll go into. But what I want you to do is, so you see the fastest shark alive, it doesn't just tell you what shark that is. So we'll go into it, and I want you to guess in the chat, what's the fastest shark alive? Beyond that, we'll give you even a little bit more information. So this shark lived 12 million years ago up until recently, although it does have an extinct form of itself. And that's what it looks like. So it is the fastest shark alive, and that is what its teeth looks like. We have any guesses out there?
We got a lot of mako shark guesses. Jason guessed tiger. Black tip from Kristen. White shark from Candace. Lots of tiger shark guesses.
It is a type of white shark, so that's not exactly wrong, but it definitely is a mako shark, and these guys are super duper fast. One of the reasons you very rarely see these in like an aquarium situation is that it would have to be an enormous aquarium for this shark to survive in. Lots of sharks depend upon, they always have to move, even when they're resting or sleeping. They have to have air, water over their gills, and so they always have to move. And if you're a really fast shark like the mako, you have to have a big tank. So yeah. Next up, this one eats everything. This shark has literally been discovered to have license plates and bricks and building materials and all sorts of things in its stomach contents. Like I said, there's tons of research going on in the sharks, about sharks and discovering them and those sorts of things. Recently, they just discovered that they found a species that made it that where there's more than 1,000 species of sharks. So they're still discovering these things. This one does have a version of itself today, but the version we talk about and the version that's this is a fake rendering of what it would look like, is right here. Kind of see some detail on the side that might give you a clue. And then that's what its teeth looks like. Any guesses out there?
So we've got bull shark, tiger shark, megalodon, great white. Let's see, lots of bull shark guesses.
Yeah. It doesn't look far from a bull shark, but it does have these stripes on the side, and that's what makes it a tiger shark. Tiger sharks are the ones that they eat everything. I mean, they you can look them up and look at the contents have been found. It's kind of comical as to what they'll try and eat. I think even one was showed up with some scuba gear. Hopefully not the scuba diver. But basically, you can see these teeth here. They look like little can openers, and their primary target, their primary prey say that 5 times, is sea turtles, because they can just crunch down. Turtles are pretty protected, but sharks, the tiger shark especially, have adapted to get around that protection. Next up is the jaws shark. I think this movie came out when I was born, so I'm not expecting everyone to have maybe even seen this movie, but or actually well before I was born. But it is the jaw shark, and it still does exist today. That's what it looks like. Pretty menacing, right? And it is often the thriller species used in movies, and it's kind of commonly the one. That's what its tooth looks like. That's probably about a medium to large size tooth of this species. What kind of guesses we got out there?
Everyone's getting this right. Everyone's
All
saying
right.
great white.
Maybe I gave too many clues there. It is the great white shark. You can see something really cool in this one that I'll stop to talk about for a second. It's called counter shading. So think about if you're a little fish in the ocean around this shark. If you're under him and you're looking up, then you're going to see this white belly. Well, the sky shining down also looks white. So the shark and many species of fish and birds and mammals all around the world have this, where they've adapted and evolved to have this counter shading. So the white on the bottom makes you maybe not see it as well, especially if the water's a little murky or something like that. Also, if you're a fish and he dives down and you're on top of the water and you're looking down, you see this dark top, and you see the ocean floor and the depths of the water also show up dark, so it kind of hides him. And the same thing with the sky and the ground. If you're a bird and you're being tracked down by birds of prey, you might not see it if you look up, and those sorts of things. So something cool to talk about there. It is the great white shark. There you go. Sorry to put that up there for leaving you guys in jeopardy. All right, so next there's actually some of my favorite teeth, but ones that are really hard to find. Right here you have the crow shark, this really unique tooth right here, and that kind of hard to and they're chipped. They're very, very thin as far as that goes. Next, you have the snaggletooth shark, and all the teeth that I'll show you that have the sand colored in them were found in Aurora out of the phosphate mines. So the snaggletooth, I think, is probably my favorite tooth. It just looks so cool. It's so different from the others, and don't we all strive to be different from everyone else? The snaggletooth shark achieved that. The bull shark here is an interesting story that I just realized that I had bull shark's teeth. I always thought that these were great. I noticed that there's this little bend in the serration side over here, right? I'm like, that's interesting. So when I was preparing this lesson a couple months ago, I looked into it and kept looking into it. I was like, man, I'm pulling these aside. It's a whole separate species. And so that's something you can do in, your everyday life or discovery is if you see something that it doesn't make sense or looks a little different, ask questions. Why is it that way? What's different about it? I always call these little baby, because they don't get much bigger than this, but they're bull sharks. I always called them little small great whites. When you're in the creek, you're like, hey, little baby great white. It's a bull shark. Sand tiger sharks, very cool, hard to find, and even harder to find with these little side pieces right here called cusps. So some sharks' teeth that are especially a extinct variety have these little side cups, and some of them have two sets over here, and that's sometimes indicative of the age of that species. Very old sharks have cusps, whereas modern sharks or newer sharks don't. That being said, there's still some in the ocean today that have cusps on their teeth. And then next up is the largest shark ever. Lived up until 1.5 million years ago. A lot of people think this shark is ancient and super old, and mainly because of its size. And a lot of people will probably get this one right as well. I'll throw you off by putting that tooth up there. That's a wee little baby version of this tooth that I found. And then this is my largest size tooth that I found of this shark. There are sharks teeth from this species that have been found upwards of 7.5 inches, almost 8 inches in length. And so just imagine the size shark that would be. We got any guesses out there? I think we
Lots
might.
of great guesses. Whale shark and lots of megalodons. Almost everybody's saying megalodon.
That's pretty much what it is. It is the megalodon shark. I did find a very cool kind of size comparison just to show you what this would look like if it were in the ocean today. Again, swimming because of the megalodon, he doesn't exist anymore. It's super extinct. If he did, he would be the size of a school bus. We would know about it, even as large as the ocean is, as much as we study. My theory is we would know about it. The great white shark, 20 foot. So he's like, if this is a school bus, this is like a Mini Cooper. And then you have us, average 6 foot in length as a human, and not all of us are 6 foot, but you get the kind of comparison. If you're swimming in the water and this school bus of a shark rode by, yikes, that would not be cool. Alrighty, so next up, I'm gonna go all the way back out. Sorry if you're dizzy on that little tour there. And we'll show you some other things that have been found. So you have vertebrae, whalebone, and coral that we can kind of go through. You also find things like that are humans have left behind, like marbles and arrowheads and things like that. I think I've also found about change over 15 years that it gets tossed in the creek or down a storm drain and into the creek. So when you're doing this, also be careful as you'll find glass out there, all the ways broken. So just be careful what you're grabbing and looking for. Sometimes a black triangle in the creek could be a really sharp piece of glass and not a shark's tooth. And next up, we're gonna kind of show you a kind of a cool thing that I stumbled upon. I was hoping to get this in today. I found it on a web page where you can buy fossilized material, and so I'm calling it a virtual shark's tooth hunt, where you can get this delivered to your house. I believe we can have this link and drop it into the chat maybe a couple times. It is expensive a little bit, but for $40, you can get a gallon of shark's tooth material sent to you. And this is done by the Aurora Fossil Museum. This is not me promoting it and making money off of it. This is them doing this during the pandemic because they are closed down. But they will send you unsifted material that's straight out of the Pungo Formation. And this is where I was finding some of these kind of, this color tooth. And that's the color tooth that you will find out of this mixture. A really cool thing. I thought it was very adaptive of them to do that. So I figured I would include it as an option if any of you wanted to do that out there. I think it's $40 and that includes shipping to wherever you are. So next up, we'll do a little bit of a show and tell sort of thing, as it were. So I will stop sharing so I have a fuller size screen here. And I will start off with a fresh shark's tooth jaw. So this is exactly what it looked like. This is and I wanted to pull this in because you can see a couple different things here. You see the upper teeth right here are a little bit kind of like the blade of a tooth. You see those? And the ones on the bottom are very skinny. So what this is a sandbar shark. What this shark does, he right now has his jaw open, right? So when he would close down, it would meet about in the middle, and the bottom teeth would just almost hold the prey. So let's say he's going after a tuna, right? He's going to hold the tuna right here, and when the top jaw comes down and cuts, it will almost be like your steak knife cutting through steak. These all have serrations on them, kind of difficult to see there. I think maybe see some of them maybe there, but essentially that's the function there. Another thing I want to show you, and I think it's easier to show you on the bottom, is how many rows are in there. You see how those rows are in there? And basically what happens is when this outside edge folds out far enough, and you either get feeding damage and they fall out, the next ones rotate up and they're right there ready to go. I thought it was a really cool example to show you. And it shows you how many, and even a medium-sized sandbar shark, how many teeth are in this shark jaw. I would say there's at least 200. I did some estimating and didn't count each one. And that's just as it sits right now, not over a period of time. Maybe that shark lives to be 20 years old. That's why there's so many shark's teeth out there. Let's get into some. So I'll start off with the tiger shark. This is the one that I call the can opener of teeth. Kind of put it there. You can see some contrast. And Tiger sharks also show up very cool in the way that their color shows up. Sometimes they pull in different materials into different parts of the tooth. So you see a little white line right there on some teeth. That's called a bourlette. That's your SAT word of the day. You can look it up, and that also will help you to identify shark's teeth because some of them have it and some of them don't. We'll go on up to the mako, and you'll see two different sizes, shapes, and variations of the mako tooth. See the one over here, it's very flat and very blade-like, and this one's kind of curved over. You can see how it's so. Version of the mako, and this is the modern day version of the mako. The color makes no difference. The size really doesn't make any difference. They're about the same size and those sorts of things. But what you'll see is that curvation, that curvy feature of the tooth will really tell you the difference in what species you have and how old it might be. Right here, this is probably my best example of a great white shark's tooth. And there you can see those serrations, or I hope you can, on this tooth. And you can see how sharp it is still. If I wanted to, you could cut a piece of paper with that. Maybe not quite my skin without any force, but still very sharp. You know, the root up here is still intact. A perfect example of that tooth. Next, I'll show you the one that was pictured, and this is the great white. I mean, it's just almost the size of my head, right? So this is a 4.5-inch tooth. It's very heavy. These are all like the density of rocks because they're replaced with minerals that are also in rocks. You have these sorts of things, and you can really see the bourlette on this guy here. You can see how it between the root and the blade or the enamel, you have this little area called the bourlette. And not very many of those of shark's teeth have that. So if you even see a small one that has a bourlette, you know that it's one of a few different types or species. A couple other cool objects that you'll find is sometimes you'll find vertebrae. This is a whale vertebrae. You can see where the spinal cords and stuff would have gone through there on either side. And unfortunately, the processes, I think they're called, on the sides, you can see that those get broken off. Those would have gone out to about right here on either side. So if this is tumbling through the creek, it's going to hit a root or hit a rock and get broken off. So very rare to find those. This is again a cast fossil, and so you can see this, you know, almost like a can't think of the species of shell it is right now. The shell is embedded in this rock. The shell is no longer here. Who knows where that is? But it sat here long enough to make this impression, and it was slowly covered up and then fossilized. Let's see, other cool ones. This is the snaggletooth. Just look how vicious looking that tooth looks. I mean, that is super sharp, especially with this little point. And then all these serrations are just really aggressive. One cool thing about the snaggletooth shark's tooth is that this is the top row, like we showed you in the sandbar shark. This is the cutting tooth. The bottom row is almost never found because it's so short, so very short. Nothing like this. It's just a placeholder while this is doing the cutting end of the business there. And I think for now, what we'll do is we'll turn it over to questions. Angela, if you had some that were out there that we'll check out and entertain.
Yes, let me go back up and get some more questions for you. Hold on just a second. We did have questions asking again about what creeks they can go look in, freshwater creeks, and then if they can find other types of fossils in other bodies of water or on land.
You can almost find fossils just about anywhere. You have to be the right elevation, is what it comes down to. Some of those fossils are harder to find. Some of those are readily available. The one that I would say, if you have never gone and never done this sort of thing, that you will almost always find at least something something fossilized, is the park. And I can put this in here. It's called Green Mills Run, Greenville, North Carolina. And that will set you up pretty good. It's like a dog park. You go over there and there's all these little drop down spots. It's really easy. If it hasn't rained in a few days, you can find the water to be about a foot deep. You don't even really need the equipment that I have. There are other parts of the creek that do get deeper with eddies and stuff like that, where it turns and it gets deep on the outside edge. So watch out for that. But you know, it's pretty easy to find them. I will say that people have had success, if you're a scuba diver, diving in rivers in the eastern and this happens all up and down the eastern seaboard. So, like if you're in Maryland, look up Calvert Cliffs. I think is a very popular spot. Lots of these places are protected because they're in a state park, but then there's ways to get permission to go in and those sorts of things. Beaches can be a way of finding them as well after a storm, especially if you have like a tropical storm or nor'easter come through like we're having right now. Then you can find things disturbed out there. You're going to find a lot of shells and a few little teeth though, and it's a little more difficult.
Great. Thanks, JP. And as JP said, you can find fossils as long as you're at the right elevation. I've been look out in creeks in Ohio even and have found fossils in the creek like this. They weren't shark's teeth, right? Because it wasn't on the coast. It's in the interior part of the country, but you can find fossils in different bodies of water. Okay, question from Natalie. If a bull shark is somewhat big, why are their teeth so small?
Well, it's about what this shark eats. So if a bull shark is one of the species that can actually can live in a less saltine environment. It can live in some of the estuaries around and some of the sounds that aren't in the ocean. And so it's typically going to be preying on different items. And so all teeth are designed or evolved or adapted to what that shark will be eating. So if this shark is eating something smaller, its prey are smaller fish. It doesn't need a huge honking tooth like this. Almost nothing now needs a tooth that size, right? And so if it just depends upon that. And if it's a big shark, it's going to have a whole bunch more of these teeth. So it has more surface area to grip these teeth. And some of our fish that live in the sounds and live on the coastlines pretty fast. So you want to have more surface area to catch those teeth, catch those fish.
Awesome. And the Deese family asked, do you have goblin shark teeth?
I do have one right here actually, and they are very common. And see, it's missing its big lobe up here. And one cool thing about see how that curve, it is very pretty how they're designed. That curve on them is what tells you that it is a goblin. Goblin shark is a very deep water shark's tooth that not a lot of people know about. So that's pretty cool. But yeah, that's a goblin shark's tooth. And you should go and if you haven't done this, go and Google search what a goblin shark looks like. Thing of nightmares, just terrifying looking.
Let's see. And then lots of folks asking if you have a megalodon tooth and why megalodons went extinct.
So we don't actually know why they went extinct. We don't really know what preyed upon them or what did they have some disease? Did something happen? We weren't here to be a part of it, so we don't truly know, and that's a big speculation. If you get into Shark Week on Discovery Channel, there's like no less than 10 shows that discuss why and what happened, and some of them say that it might still be out there. I think that's kind of a conspiracy theory, though, because something that had a tooth this size, I think we would know about, right? That's with all the sensors and cameras and diving and all the things that we do, we would know about this being out there in the ocean. And I forgot the first part of that question. Have I found one? Yeah, this is one. So I found probably, I'm going to say around 20 or 30 megalodon shark's teeth. I have one actually that's made into a necklace. It's not near that big because don't want to weigh myself down, but you can find them in all different sizes and shapes and forms and things like that. I've probably found around that many. Yeah.
Very cool. And we are right here at the end of our session. So I'm sorry for those of you that we didn't get to answer your questions. Lots of great information here from JP. Before we wrap up, I do want to share my screen. Hold on just a second. We've got a neat thing that we want to try out with you guys. Have any of you used Flipgrid before? This is a new digital tool that teachers have been using as we've been going through this whole virtual learning thing, which I know many of you are virtual learners as well. But this is a platform where you can actually upload a short video and tell us about your fossils. I know a lot of you have been sharing in the chat window that you went gem mining and found some cool rocks recently, or that you've got fossils of shells or shark's teeth or even petrified wood. And this is a way for you to show and tell back with us. So what you'll do, I'm going to put a link in the chat window. Give me just a second for that. There you go. And when you click on that link, it will take you to the screen that I was just sharing, and then I'm sharing here again. And you can scroll down and record a response, and you'll have a 1.5-minute window to show and tell us about your fossils that you have at home. Or if you want to go out and explore a creek and see what you find, you can come back later and tell us about it then. This will be up and out there for you to use from the link whenever you would like to. Or if you want to check out the Aurora Fossil Museum and order one of their fossil sifting bags like JP was talking about earlier, you can do that and then come back and share with us what you find. And you'll be able to see your peers, everybody that's here. And even if you're out there watching the recording, you can do this as well. With this share code, we'll send it out in the email after today's presentation. All of the videos and comments will be moderated. So that means JP or myself will be looking at them first before we will share them on this Flipgrid prompt. So please, make sure that your videos are appropriate. If they're not, we're not going to share them. But we would love to give you the opportunity to show and tell what you found or what you have at home with your fossils. So again, that link is in the chat window. We will send it out in the email. You do have to have a Google or a Microsoft email to be able to do that. So when you record a response, it'll ask you for your email, and you can put that in and then submit your response. We definitely want to hear from you what you've got going on out there. And let's see, a couple more announcements. This was our last nature adventure for the semester, but we're hoping to come back in the spring. If you're an educator or a parent out there and you would like to give us some feedback, I am putting a survey link in the chat window. We would really love to know what you like about nature adventures, and then also what we can do to improve for the spring. We're going to have a whole new series of topics, and it should be really fun. It's been a fabulous learning journey with all of you who have been coming time and time again, and welcome to those who were new just for this session. We hope you've been inspired to get outside and explore the natural world all around you. Take our survey, let us know what you think so we can improve for the spring. Have a wonderful and safe holiday season, everyone. We'll see you back in the spring. Bye.
Enjoyed it, guys. Take care. Great questions today. I really enjoyed today's session. And go out there and find something or show off what you've already found.